Hi, I'm Andrew, and this is part 3 in my Advent of Code series where every day I solve or attempt to solve a series of code challenges. The previous videos that I've recorded are available on my channel. I have a playlist for Advent of Code 2022, and any code that I write, if I'm able to solve the challenge, I will upload it to my public repo, and that's available in the description in the link. I've got my apple cider ready to go. I'm ready to code. Let's get started. So for today, the challenge is rucksack reorganization. One elf has the important job of loading all of the rucksacks with supplies for a jungle journey. Unfortunately, the elf didn't quite follow the packing instructions, and a few times now they've needed to be rearranged. Each rucksack has 2 large compartments, and all of the items have a type that are meant to go into exactly one of the 2 compartments. The elf that did the packing failed to follow this rule for exactly 1 item type per rucksack. So the elves made a list of all the items currently in each sack, and that's our puzzle input. They need our help to find the errors, so which item is incorrectly organized. Every item type is identified by a single lowercase or uppercase letter. So based on the case of a letter, they could be different items. The list of items for each rucksack is given characters all on a single line. Okay, so each line is going to be a separate sack, and then each character is going to be a different type of item. A given rucksack always has the same number of items in each of its 2 compartments, so the first half of the characters represent items in the first compartment, while the second half of the characters represent items in the second compartment. So, yeah. So for an example, if we have this list of our items, it looks like each row is going to be a different rucksack, and then the first half is going to be the different compartments. So let's look through the example. Yep, so that means that the first compartment contains the characters up through here, and then the second compartment would be the rest of the items. The only item type that appears in both compartments is a lowercase p. Alright, and the second rucksack's compartment, it looks like we need to check for each rucksack which item type appears in both compartments. So in this case it would be the uppercase L. For the second rucksack, the third would be an uppercase P. Okay, so then to help prioritize item rearrangement, every item type can be converted to a priority. So lowercase item types have a priority of 1 through 26 based on where they are at in the alphabet, and then uppercase items, they go through the same thing, but they start at 27. So in the above example, the priority of the item type that appears in both compartments would be 16 points for a lowercase p, 38 points for an uppercase L, and so on. The sum of these is 157. So what we need to find for our answer is the item type that appears in both compartments of each rucksack, and what is the sum of all of the priorities for those item types. Alright, so we've got a good amount of parsing logic and mapping to assign some points. Yeah, let's check out the puzzle input and get started. I'm going to take this and copy it in to the code editor. Okay, so we're in day 3. I'll put that in here, and what we're going to need to do is just start by splitting out the compartments. So for each rucksack, we're going to need to take the first half and put it into its own group, and then we'll have to compare the first and second one at a time to get which item is not organized, and then from there find the point value for that, and just do that for each one and then add them up together. So let's start by figuring that part out. We're gonna make some functions for splitting into two groups. So let's take our input in part one here, and we can map this to a new list, and the list will have pairs of the first and second compartments, since they should just be the same type, just a list of characters. And we're going to split it in half. What would be the best way to split it in half? We can maybe use a partition, but with that we don't know the index of each, so we could just create a new pair and put the first half by taking the size of it, or the length. We can know the length of the string divided by 2. So if we were to take the first half, that'll give us the first pair, and if we drop the first half, then we know that we have the second compartment. So let's do that and just see if it looks right. Yeah, and we'll go from there. So this will be our rucksacks list, and we're just going to debug this and check what the value looks like. So in each of our mappings, we've got the pairs separated. Let's just make sure that they are at the right point. It looks like they all are. They're not repeating any characters. We want to make sure that none are being skipped. So for this first one, the first group ends on the lowercase z, and then it picks up at the uppercase B, and that's what it does here. So it looks like the splitting logic is good. It said that in the instructions, it said that they all should be the same size. So I don't think that we'll have to worry about any odd number of length. All right, so back to the program. Let's figure out what to do from here. The next step would be to find which character is duplicated from each of the rucksacks. So what we can do is we can take we'll want to make a function that takes a pair and returns the letter. So let's just start by doing that. We'll make an extension function on pair of 2 strings and call it get duplicate. And that's going to return a single character. So what we can do here is we could find compartment 1 is going to be first. We need to set it as a value. So compartment 1 is first, and compartment 2 is second. And that's coming from the pair that we're on, so it'd be the same as doing like this dot second. And we need to return we need to return what is in both lists or both strings. So one thing we can try is getting rid of any duplicates in each list. And then we can sort them, and then we can just go through the list until whichever list is longest. I think that might work. Let's try this. So if we take the first compartment, let's distinct. We're going to turn it into a list of characters first. To list, and then distinct. Distinct is going to make sure that there's no duplicates within, within the list itself, and then we're going to check separately if there's duplicates between the two lists. And we'll debug this quick just to see what our lists look like. And hopefully we should be able to see. Oh, we didn't use this yet, so we want to return. We'll go off of the pair and take. Actually, we can leave that alone so that the rucksacks will still just be the list of pairs. So for a rucksack, we'll say for each, we're going to call our get duplicate on it. Now this isn't going to return anything yet because we haven't figured out the logic, but we're just going to debug what's happening. So under here, compartment 1, they both have the same size. They both include the same number of characters, but one character from one list should also be present in the other. So we can't, well, actually that makes it kind of simple because then we can just take, we could set a variable which will be the duplicate, name the duplicate, and we're going to leave that as just a blank character. We're going to return the duplicate and make sure that that's a character, but we could just put that in single quotes there. Won't let us assign an empty. So yeah, no, that's fine. We'll just take compartment 1 and we're going to go, let's see. We're going to set this duplicate to null until we're ready to return it. Let's say that it's the type of character, it's nullable, and we'll say that it starts out as null. So that kind of solves our problem, and we'll just assert that this is non-null when we go to return it. So for compartment, we're just going to do a loop for each, and we're going to check if compartment 2 contains this character. If it does, then that means compartment 2, that character would be the duplicate between them both. And we'll assign duplicate to our character. We'll rename this. All right, so now I'm just going to rerun this in the debug, and hopefully we should have a value that got set. So here it's showing that the duplicate was Q. Let's just look at the lists and see if that looks right. So compartment 1 has a lowercase q, and compartment 2 also has a lowercase q. So far it looks good. As we continue running it, it looks like there's always a result. Um, but here we could see that there can actually be a difference in size, and so that becomes a problem if one is longer than the other, because we might miss some values. Um, but actually, I don't think that matters because we don't need to check every combination. We just need to check. Yeah. So even if the list we're checking through is shorter than the other one, we're not mapping like the same index, so size shouldn't matter for the lists. I can assume that this is going to work like we want it to. So the next step is going to be getting the point value. Yeah, let's try that. I think we can actually get. I think we can get the number value from a character by turning it to an integer. We'll see. So once we get the duplicate character, we're going to make another function on a character to get the point value, and that's going to return an integer. So what we could do once we get each duplicate, we can take its value and we can say character we can do this and get its point value. And just for debugging, we're going to put this here, points, to get point value. And we're going to print out the points. But for the debugger, we could just look at what that is. Here, I think we can say this to int. And character code. So yeah, let's see what this does. Code. We're gonna return it. We're already scoped into this, so we don't need to write it. Yeah, let's debug. So when we hit here, it shows the character queue. The code is 113, so I don't think that's going to work out too well. I thought that there was a way to make a list like this. To integer. That says 113. What are some other functions we have? To digital to int. Yeah, okay. That's fine. I think we can make a list of all the characters from A to Z, uppercase C, and then get the point value from their index. I think that will work. So if we do we do this, we can say our character list is I think we could do an A in a range to Z. I think that will give us all of the letters in between. Maybe if we even put an uppercase Z, it will do them all. I'm not sure. Here's our breakpoint. We can just test it in here. We'll evaluate the expression and run this. So A through uppercase Z is going to give us a list. Oh, we need to make it into a list. list of. I think that'll make it a range. Okay, so here we go. No, it's not working. I know if we go like 1 through 10, we can get a list. To list, if we do this, yeah, that'll fill out 1 through 10. I think if we do characters, it'll work as well. Yeah, okay, so if we do it, okay, if we do a lowercase c, it's going to work, but I think if we bump it to an uppercase c, then it doesn't know what to do. But if we have an uppercase A, then it also works. So this is what we could do. We could just make two lists and then add them together. I think that will get us where we want to be. So under our get points value, yeah, we'll make a lowercase list, char list lower, and list upper. And we'll do the same thing, but for uppercase letters. So now when we make our character list, we can take the lower list plus the upper list. And that should give us all the numbers, and I think that it started at 1 for the points instead of 0. Yeah, so 1 through 26 indexes are going to start at 0, so we'll just want to make sure when we're getting the points that we add a value. So what we're going to return is the character list index of, so we can find the index of the value that that we're extending from, and we can add 1 to it. I think that will work. So now when we debug this again, we should have a good value for what we're debugging. Yep. So here, Q, it's not actually 113. It's the points is 17, and I think that's probably good. Uppercase F would be high points. Let's see. These all look good to me. Yeah, B would be 28 because A starts at 27, right? Okay, so I think we can use that. Now we just need to sum all of those. So we can, the rucksacks we can sum by, or sum of, and we can take it, get duplicate, get point value. And that should give us the value that we need. Let's try this for part 1. It's just going to print it out here for our output. So 8,240. Let's check that. Okay, submit, and that is the correct answer. Good. We're going to move to part 2 then. So for part 2, as we finish identifying the misplaced items, the elves come with another issue. For safety, the elves are divided into groups of 3. Every elf carries a badge for identifying their group. Within each group, the badge is the only item type carried by all 3 elves. That is, that if a group's badge is item type B, then all 3 elves will have item type B somewhere in their rucksack, and at most 2 of the elves will be carrying any other item type. at most. Okay. The problem is that someone forgot to put this year's updated authenticity sticker on the badges. So we're going to have to find out what it is. All of the badges need to be pulled out of the rucksack so the new authenticity stickers can be attached. Additionally, nobody wrote down which item type corresponds to each group's badge. Only way to tell which item type is the right one is by finding the item type that is common between all three elves for each group. Every set of 3 lines in your list corresponds to a single group, but each group can have a different badge item type. So in the above example, the first group's rucksacks are the first 3. So from this example, that's taking those 3. Second groups are the next 3 lines, okay? And in the first group, the only item type that appears in all 3 rucksacks is the lowercase r. So for the first group, we have r, lowercase, lowercase r, and lowercase r. So this must be their badges. In the second group, their badge item must be z. Second group, we have an uppercase z, and uppercase z. Okay, so priorities for these items still has to be found. So here they're 18 for R, 52 for Z. Okay, so we have to break them into groups, find the common item between 3, and then find the common item between 3, and then we have to add them up for each group. Okay, I think we could do that pretty closely with what we've already written. We already have these extension functions for kind of figuring out those values. Instead of a pair, we will need a tuple, I think. So let's just copy that. Instead of a pair, tuple, triple. It's triple, there we go. Triple, string, string, and string. So it's going to work the same. Compartment is first, compartment 2, and then we just have compartment 3. Actually, no, that's not quite right, because I think we're still, are we still checking the first? No, I don't think we're splitting them in the middle anymore. I think now, instead of splitting them in the middle, we are, okay, so we can just repurpose this. So here we would have compartment 3, and that's going to be third. Okay. And what we'll do is just add that inside of our loop. So if compartment 2 contains the character and compartment 3 contains the character, okay, so then for part 2, we just need to copy over some of this logic, but instead of splitting out each line, we're going to split out the groups of every 3 lines. So we'll create a triple, and we're just going to put groups here instead, groups, and we're still going to sum the same way. And I think we can get point value, let's see, groups, what is that going to be? Okay, it's because it needs a third item. So now we're good. Now we're for part 2, we know we've got a triple with 3 strings. But we're gonna have to map them a little bit better. I think we can just loop over to create our 3 groups instead of mapping each line. So yeah, we're going to say we're going to get 3 elf lists, and then we're just going to add them to each group as we go. So we're going to create a group of group 1, not group, elf list 1, and we're going to make that a mutable list of string. We'll say elf list 2 is a mutable list of string. It looks like the top one I made a set, which is probably fine. We'll just do a list and make a third one. I think that's what we got figured out. The second group's rucksacks. So each elf has their own rucksack, and they're in a group of 3 elves. Yeah, I think this will work. And so we'll just go through and say input for each. We'll say for each indexed, and if yeah, okay, so we could say if the index, the modulo of it of 3 equals 0, that it is no, I don't like that quite as much. What we'll do is we'll do a counter and just loop it through to know which to put these in, and say counter start at 0, and put our input and say for each, and we'll just check the counter to see which list to put it in. If the counter is we'll just do a when, because we know each of these cases when counter, and we'll say when it is 0, we will say elf list 1, we'll add it. We're going to say rucksack here, and we'll just duplicate this down and say if the counter is if it's 1 or 2, we'll go to list 2 and 3. But actually, if it's 2, we're going to no, we need to increment this at each point, and we'll just do that here. So if it's 0, when we get to the counter, we can increment the counter. When it's here, we'll increment the counter. But if it's here, we'll just say the counter is back at 0. Okay, I think that will get us each of these filled out evenly, but let's just run the debugger here to make sure that we have, I think there was 100 or 300 lines, so we should have 100 in each list. Yeah, let's run this. Okay, so here we've got, yep, 100 in each list. And we should have, if we look at elf list 1, the first one should be our top, which starts with PQG. Let's check our input. The first one in the list starts with PQG. The next one should be BDG. And if we look, the second one, yep, so it looks like it's going every 3. Okay. Now what we've got to do is put these each into new groups with these triples. So what we can we could put these together Probably did this a little backwards when we were creating these, but that's okay. We'll just have to have one more step to kind of zip these together. Health list. We'll just do this. We'll say groups is a list of, or immutable list of triple string, and then we'll go through these. We'll just start with elf list 1 for each. We don't need this anymore. We're going to say the elf list for each, we'll say groups. We're going to add a new triple. And the first is going to be, we need to do this for each indexed, because we're going to use the index to map across the other lists as well. So we'll just do that. So triple, we're going to add the string for elf list 1. We're going to add elf list 2, the index, and elf list 3 index. So that should get us the groups correctly, and then we just have to get the duplicate and then get the points. And I think we've got that here because we already have an extension on duplicate. So let's just run this and check our input. It's going to be the second one in the input. So 2,587 is the total. And let's see if that is good. All right, that is the right answer. So we're 1 gold star closer. I've got 6 gold stars now, and that's it for the challenge today. I'll be cleaning up some of the code that I wrote, and then I'll upload it to my repository. But I'll just come back tomorrow for the next challenge.